we've done this before, okay? And what we did before was we brought B to the junction, okay? We brought B to the junction such that B was here, and it was basically 100 minus, it did it in 5 seconds, right? Because 5 seconds, 100 divided by 20 is 5 seconds. So B is here at the junction. A is now 100 minus 10 multiplied by 5, which is 50 meters away. Okay? Now, and we then worked out the relative velocity like we did normally, okay? PAB. So we knew that PB was minus 20I. We know that VA goes 10 down, and VA was, we've done this all before, we worked out the tan of the angle, the opposite and the adjacent. We have no problem with this. It's 8 and 6. So VA would have been, what's it called? 8I, sorry, minus 6I minus 8J. We then proceeded to do VAB, which is VA minus VB, and...
There's not 6 and 8, you're off the way around.
Oh, sorry, opposite adjacent, you're right. Sorry, that's opposite adjacent, this the other way around. So, 6 and 8, so it's 8I minus 6J. Then we took them away from each other, okay? So we got VA minus VB. And what we ended up with was 12I and minus 6J. Now, our problem at the time was that this 12I minus 6J, what happens is, it's 12 across 6 down, and so 6 and 12. And what we did was we tan inverse the half. What did we get again? 28.33, was it?
Yeah.
Just don't go by memory. Let's just tan inverse the half. Let's tan inverse the half just to make sure. And what did we get? So we got a calculator. Be your brilliant. Tan inverse the half.
26.565.
26.565. That's grand. Now, what happened here, guys, was that we said, like, we couldn't actually make the triangle out of it because, as we can see, it's going further away than the 50. Okay, so that's the problem. Now, a way that works, I showed you one backup already, where you go back to the start of the question, and that backup is a bit more complex. You can do it, but it can be complex. But what you're going to find is that when you have one of the roads that is on the XY axis and the other road that's a diagonal, the best idea is actually to take this one, the one that's on the diagonal path, to the junction. So instead of taking B to the junction, let's take A to the junction. So in another 5 seconds time, in 5 seconds time, A will be at the junction. So this is 15 seconds further down the road, or is it? Sorry, it's 10 seconds down the road. So you started off 100 meters away. Would you agree with that? Yeah. Divide it by 10. So this time we're going to put A at the junction, and then now that A is at the junction, B therefore is over here. And look, that's a much nicer looking angle to do this with. Okay, so A to B this time. B has travelled for 10 seconds. It's travelled 200 metres in this direction here, which means it's 100 metres through the junction. Now all of a sudden, your VAB, which way is it now? VAB. Moment. It is that VAB, okay? It's very much, we're just going to extend it backwards, I reckon, is what we're going to do here. So, we have this line here, the 12I minus 6J going this way. And what we're just going to do is we're just going to go, this is its path back where it was. So we're assuming that, like, it's obviously the closest approach is long gone. The closest approach is long gone because it was 50 metres apart at one point in time, wasn't it? and now they're 100 meters apart once A is at the junction. But the trick still holds true that you can just do it like this, and then there you go. That's your BA relative to B path. Okay, and what you're looking at here is that this is this angle. What did we say that angle was again? What did we say this was? 26.565. Opposite that. Remember the opposite rule? A equals A. Yeah. Then we got this one here. Is 26.565. Okay, now we're trying to work out the closest distance. That's that distance D here. So we can zone in on this triangle here. See that triangle there? So therefore this triangle here, this triangle here, and we go this way, then A, B, and then that other way there, and then we get 26.565, D being here, 100. So guys, what function are we going to use to find the D? What side is D? Opposite or adjacent or hypotenuse? Opposite. So we're going to get sine 26.565 is going to be equal to, that is going to be equal to D over 100, and finally D equals 100 sine 26.565, and what's that in the calculator? Hopefully 47 or 44 point something. 44 point?
721.
That's correct. Okay guys, so I've done this two different ways now. Okay, I've done it from the start. I've done it now with taking the diagonal one to the middle, that one to the end, and then you just have to retrack your step backwards and then find the perpendicular distance. So the quickest way regards exam technique is always whichever one is on the diagonal road, put that one at the junction, put the other one where it lands, and if you have to track backwards, do it, and it works out quite easy. They have opposite angles here and here. It's a much quicker way than the other way I would have showed you with the more complex angles. Alright guys.